Hello students, welcome to my channel Dilip Pad Official. Today we will discuss chapter force, which is the second chapter of physics and 11th chapter of class 9th. In the last chapter, we discussed about the motion, chapter motion. In the chapter motion, we only discuss velocity, acceleration, speed, and equation of motion, how to find distance, how to find final velocity. But in this class, we will discuss what is the cause of this motion. What is the cause of this motion? The study of the motion along with its cause is called dynamics. Study of motion is called kinematics. Study of motion along with its cause is called dynamics. And the cause of motion is force. Force, what can do? What can do the force? Force can do many things. Force can change the direction of state of direction. Force can change the state of rest. Force can change the state of motion. Also, force can change the shape and size of the body. To change the state of rest into motion, to change the state of motion into rest, or to can change the direction, an unbalanced force is required. But to change the dimension, unbalanced force is not required. Balanced force can also change the shape and size of the body, or it can change deformation. So, balanced force is deforming force. Unbalanced force cause the body accelerate. For the acceleration of the body, an unbalanced force is required. At first, the idea of force was given by Galileo Galilei. He told that to change the speed, an unbalanced force is required. And later, it was broadly and very finely understood by Newton's laws. Force means it is an external agent which can change the rest body into motion, the moving body into rest, or it can change the direction, or it can change the shape and size of the body. Again, how this force applied on a body? Force can applied. It is applied, but it is common to play due to interaction of one body with another body. And force, it is a vector quantity. Force is a vector quantity. Its SI unit is Newton and CGS unit is dying. What are the consequences of force? I have told earlier, it can change the state of rest or state of motion of the body. It can change the speed of the body. It can change the direction of motion of the body. Also, it can change the dimension of body. These are the consequences of force. It can change the state of rest into motion. It can change the state of motion to rest. For to change the state of rest or to change the state of motion, to change the direction, to change the speed. For these three things require unbalanced force. What type of force required? Unbalanced force. But for the fourth one, to change the dimension, not unbalanced force required. What type of force required? Balanced force. Balanced force only can change the dimension, not can change the speed of the body. What is balanced force? Let us suppose a single force produce same acceleration on a body if a number of forces produce same acceleration by acting on the same body, then this single force is the resultant of a number of forces. Understand? If a force produce same acceleration when a number of forces produce same acceleration acting on the same body, then the single force is called resultant force of the number of forces. Can I erase it? A single force which produce same acceleration produced by the number of forces produced by number of forces acting on the same body then that single force is called resultant force of this number of forces of this number of forces. Resultant force is also called net force. Is also called net force. If the net force is zero, then that is called balanced force. If the net force is not zero, then that is called unbalanced force. Let us suppose a body travels in a straight path with a uniform motion. For this uniform motion, no force is required. That means here resultant force is zero. That means the number of forces may act on this body, but the resultant force is zero. If the body is accelerated, that means speed changes or direction changes, then the force is unbalanced. Otherwise, the net force is zero. No force is required to keep a body in uniform motion along a straight path. Here, net force zero means balanced force. Net force not zero means unbalanced force. Suppose here is an object. Here force F1 is acting at 10 Newton towards right side. Another force F2 which is applied towards left side, that is also 10 Newton. Here net force or resultant force, if we consider right side force is positive and left side force is negative, then F1 plus minus F2, that is 10 plus minus 10, 0 Newton. And this is balanced force. If two forces act in the same direction, let us, this is F1 10 Newton, about 20 Newton. Here F2 10 Newton. Here both forces acting in same direction, acting along same direction. In this case, they are acting in opposite direction. In this case, they act along same direction. Then resultant force F is equal to F1 plus F2, 20 plus 10, 30 Newton. Similarly, we will take another example. Let us suppose a force is acting towards right side is 30 Newton. and from towards left side 50 Newton is applied. This is F1, this is F2. Here net force F is equal to F1 plus minus F2. 30 Newton plus minus 50 Newton. Minus meaning means the force is applied to the left side. That means 20 Newton force is applied to the left side. This force is applied towards the left side. Now, we will discuss about the first law of motion. Force also again divided into two types: contact force, non-contact force. Push, pull, friction, these are contact force. But gravitational force, electrostatic force, and magnetic force, they are non-contact force. The force which is applied on a body with physical touch, but physical contact, then that is called contact force. If a force is applied on a body at a distance, then that is called non-contact force. Non-contact force is always inversely proportional to square of distance. That means when distance increases, non-contact force decreases. When distance increases, non-contact force decreases. That I have told three types of non-contact force: gravitational force, electrostatic force, magnetic force. Among them, electrostatic force and magnetic force, these are either attractive or repulsive. But gravitational force is always attractive force, which we will discuss in the chapter 3 of physics. Newton's first law of motion. First law of motion. A body is in the state of rest or motion it will continue to remain in its same state of rest or motion until it is acted upon by an external unbalanced force. An external unbalanced force. We can divide this law into two parts. A body is in the state of rest or state of motion. It will continue to remain in its same state of rest or same state of motion. This property of the body is called inertia. This property is called inertia. What is inertia? Inertia is the property by which by which a body try to remain in its same state of rest or motion. Inertia is the property by virtue of which a body always try to remain in its same state of rest or motion. Inertia depends upon which factor? It depends upon mass. Inertia depends on mass. It increases with it increases with increased mass. If mass is more, then inertia is more. If mass is less, then inertia is less. A tri-rickshaw is standing on the road. We can move it by applying our effort. But we cannot change the state of rest of a bus by applying our effort. We require 5 to 7% to change the state of rest of a bus because bus is heavier than tri-rickshaw. So it requires more force to change its inertia. The first part of first law gives the definition of inertia. Second part, the external agent which changes the state of changes the inertia of rest or motion, that is called force. The external agent which try to change the inertia of rest or motion or direction is called force. The external agent which try to change the inertia of rest or inertia of motion or inertia of direction, that external agent is called force. Hence, Newton's first law of motion gives definition of inertia. First part gives definition of inertia. Second part gives the definition of force. This inertia is of three types: inertia of rest, inertia of motion, and inertia of direction. If we give the example of inertia of rest, suppose you are inside the bus in a stationary bus. The bus is suddenly started its motion. What happens to you? You jerk backward. Why? Why you jerk backward? The bus was in the rest position. Your body is also in the rest position. When the bus suddenly started, the lower part of your body, which come in contact with bus, that comes to motion. But upper part of the body, due to the inertia of rest, it remains in the same state of rest. So you jerk backward. Why a coin put into the glass. When we strike the card, let us suppose this is a glass, a cardboard is there with a coin. If we strike the cardboard, the card will go forward, but coin will put into glass. Coin will put into glass because when we apply force, the card is come into motion. Due to inertia of rest, this coin put into it is in the same position, so it put into glass. Similarly, when we shake a tree, what happens? The dry leaves fall down or fruits fall down. The fruits and leaves, which are loosely attached to the plant, what happens? When we shake the tree comes into motion. But due to inertia of rest, the fruit or leaf, they try to remain in the same state of rest and they are loosely attached, so they detach from the plant and fall down. There are so many examples regarding the inertia of rest. These are three examples I have given. Similarly, if we discuss about the inertia of motion, when a moving bus suddenly stopped, what happens? We jerk forward. Why this happened? The bus and our body both are in motion. When the bus suddenly stopped, our lower part of the body comes to rest, but upper part of the body, due to the inertia of motion, move forward. So we jerk forward. Can you tell me why the dust particles fall down when we hit a blanket? Dust particles are trapped the blank spaces inside the blanket. When we strike the blanket comes into motion. But dust particles, due to inertia of rest, they remain at the same position, so they fall down. If we discuss about the inertia of direction, a bowler throw a ball to the batsman. When batsman hits the ball, then ball changes its direction. As long as force is not applied, the direction will not change. And this is all about the Newton's first law of motion. In the second video, we will discuss the Newton's second law of motion. If you like my video, share, subscribe and like it. Also you comment. Thank you.